In this video, we'll talk about vectorized string operations in pandas. Vectorized string operations are simply operations on string values that are being performed on the whole series in pandas rather than on a single value. To start this discussion, I'm going to revisit some of the string operations here. So let's say we have a series of string values, such as this list of string values in the list called data. Let's say I want to capitalize each one of these values here. Well, what I can do here, I can write a list comprehension that basically calls the function s.capitalize for each s in data, and I get another list that contains these string capitalized. Now, so far so good. The problem with list comprehensions, or the problem of applying this function on each one of these elements in the list, is that it assumes that all of them have a function called capitalized. Obviously, it's not the case if we have an integer here, because integer doesn't have a capitalized function, right? That's usually not an issue because we expect the values in the list or in the series, as we'll see in pandas, to share the same data type. One of the issues is the null values, because the null value doesn't have a function called capitalize or any function of the string data type. So if we try to do something like this, that doesn't work very well. As you can see here, we get the error none type doesn't have an attribute capitalized. So already, if we try to use list comprehension in order to process string, we kind of see what kind of problems we will be facing. Let's take a look at this example in pandas here. So, well, before doing this example, let's do an example with this one, with this list. I'm going to create a series. Here, let's call this one S from this list. Let's import pandas. I'm going to import NumPy. I'm not sure if I need it, but I will import it here. Okay, so let's create a series here. That's the series S. Now, if I want to capitalize each one of these values, I can write a list comprehension. So I can do, x.capitalize for x in S. And I can convert this to another series if I wish to. If I wish to have a series 2, for instance, that contains the capitalized version. That's one way to do it. The other way to do it is to use the function apply. So I can do s.apply, and the function here that I want to apply is capitalize. So I'm going to take a look at each one of my x values in the series, and I want to call the function capitalize here, and I will get something similar to S2. That's basically the same result. So if we have a series of string values or a data frame that has a column which is string values, we can either use apply or we can use a list comprehension. I always prefer using apply. Now, we still haven't solved the problem of null values, because if this series contains a null value, such as in this example here, if I apply the function lambda x.capitalize, I'm going to get an error because, simply speaking, none type doesn't have an attribute capitalized. So then I need to make my function more complicated. I want to say something like this. I can say, okay, x.capitalized if x, else none, and that would work. What does that mean? That if x, and don't forget that the none evaluates to false, and if it's not null, if it's not an empty string, it will evaluate to true, so we will call capitalize. Otherwise, I keep it as a null value. So, but you notice here that the function is now kind of overcomplicated for what it's trying to do. Now, for all of these string operations, including capitalize and many of the string functions, pandas provides a built-in way to apply those functions on a series. And we can access these pandas functions by calling in str attribute after the series, and then call one of these functions. And those are the functions are here. For instance, if I want to capitalize, I can do names.str and then capitalize here. That will basically apply the function capitalize on all of the values in the series, and it will deal with the null values gracefully. Now notice that this is not it has the same name as the capitalize function in string data type in Python, but it's a different function. It's basically pandas is implementing a wrapper over all of these functions for them to operate on a series and for them to deal with null values as well. Now the other value of using the string vectorized string operation is that they are optimized and they are more efficient than the built-in functions. Once again, this is not usually an issue for small to medium-sized data sets, but it becomes an issue if you have a larger data set. So for instance, here we have on average 343 microseconds to do this operation. If I want to do it my own way using the apply function, it will probably take more than that. So it took a bit more than that, not that bad. But it remains the case that those functions are optimized for efficiency, and they also know how to deal with null values. Next, we're going to do some exercises here, some practice of these functions. Let's say we have a series of people name. If I want to lowercase all of those people's names, I can do the name of the series .str.lower. Again, don't forget str. You can't do something like this because this function is not an attribute of the series. It's an attribute of a sub-module in the series called str. So for organization purposes, they put them under str. If I want to calculate the length of each one of these string values, I can do str.len. Starts with t. Which one of them starts with t? If I want to split, that's the split function, and it's going to give me a list for each one of the string because we are splitting, and by default it splits around a white space. Obviously you can change that. If you want to split around an edge, you can do that. You can provide your delimiter here, very much like the string function, but again by default it splits around white space. Now, it's worth noting that those functions, they're called vectorized string operations, but they also work for sequences which are not string, as we will see. For instance, if we have list, we can still access the str list of functions, the set of functions that work on str, and some of those functions will operate on the list themselves. For instance, if I want to calculate the length of each one of these lists, I can do str again, and I can do len. And I can see here that all of them have two items, first name and last name. So once again, when I do str.split, what I get here, if I take a look at the first element, I get a list of two strings, right? But some of the functions, some of the vectorized functions also work on a list. They're not confined to working on a string. If you do str.length, that's the number of characters in a string. But if you have a list, that's the number of items in the list. Okay, so we will revisit this shortly, but let's talk a bit about regular expressions for now. It turns out that these vectorized string functions also implement many of the regular expressions functions. And those regular expressions functions are kind of implemented to match the corresponding functions in the regular expression module with some differences. And notably, the function extract it doesn't exist in the regular expression module. It does matching for each element. So it extracts, it keeps matching until it matches all of the, it exhausts all of the string. Similarly, the function replace is kind of like the function substitute in the regular expression module. Apart from these kind of minor differences, these functions behave the same, except that they operate on a series. Okay, so let's take a look at some of the examples here. Let's take a look at our series of names. Now, if I do extract and I provide my matching group to be any letter A to Z, now notice the bracket here, any letter A to Z, and any small letter A to Z repeated, it means that I want to match only one word. So if I do extract here, I'm going to extract the first word in these strings here. If I take out that optional parameter, expand, it's going to put it in a column in a data frame. So in this case, I get a data frame rather than getting a series. The function findAll, on the other hand, will find all of the occurrences of this pattern in the text. So if instead of doing extract, I do findAll here, it's going to give me all words, so it will match, and it keeps searching, so it will match the first name and then the last name, first name and the last name, and I get a list of names here rather than getting only the first one. Let's take a look at this example here. This example here is trying to find all, starting from the beginning of the string, that's the beginning of the string, and ending at the end of the string. Now, what is it looking for? Well, it's looking for any letter which is not, now notice this symbol now means something else because it's in a bracket. It means look for any letter which is not A, E, I, O, U. And then look for any letter repeated. And then look for any letter which is not A, E, I, O, U. That basically matching people's name, and the names start with a consonant, not a vowel. A, E, I, O, U are vowels, and ends with a consonant. It's an interesting example here, not very useful in practice, but there's basically matching peoples who have names starting with a consonant and ending with a consonant here. Now let's take a look at some of the other methods, the useful methods that we can do here. Notice that we have access to the method get, which index each element, and the method slice, which slice each element, as well as the method slice replace, which replace the slice in each element with a value. Those methods are very useful because they allow us to actually get access to a specific element when we have a list. When we have a string, we will get to a specific character, so that's not very useful, but they become useful when we have a list of items. Let's take a look at some of the examples here. Let's take a look at the get method. So the get method I can do, let's say I want to only extract the first character in the name. I can do Monte here, str get 0. That basically gives me, let's take a look at the names again, the first character in each one of these names. Now, as a shortcut, if you don't want to use the get, you can do str and bracket 0. That's basically the same. Similarly, we can slice. If we want to get the first 3 characters, we can do get monte.str 0 colon 3 or monte.str.slice from 0 to 3. That's the same, okay? So now notice that the bracket now means something else because you put a colon, it means it's a slice. So those are the two methods here, get and slice. Now those methods, as I said, are very useful if we have list. For string, it's rarely the case that we are interested in specific characters in a string. But when we have list, it's usually very useful to get a specific item in the list. Let's take a look at this example here. In this example, let's say I want to get the last name of each one of those people. And don't forget, those are all strings. So what I do the following. I do str split, and this will split each one of the string, resulting in a list. Now, how do I get the last element in the list? I index the list going -1. Now, don't forget the str. If you do something like this, if you do at -1, you're going to index the series. And there is no key -1 in this case here. So that doesn't work. You need to do str and then index each one of these lists. So if you do str -1, that's going to give you the last name because it's the last element in the series. If you do str.get -1, you get the same. So either this one or this one. So this one will get -1. Okay. So you can break the last name and the first name here from your series. So that's very useful because now you can split your names to first and last names if you wish so. The last feature that I want to talk about is called getDummies. Now, getDummies is basically a function that changes a string variables to a bunch of other variables based on its value. This is very useful if the string variable is used to indicate categories. And this is something we will take a look at when we look at machine learning, because many often we want to convert categories to numerical variables. So a dummy variable is basically a variable that is 0 when the category is absent and 1 when the category is not absent. If you take a look at this example here, for instance, you can see that the variable info is basically encoding some categories, B, C, D, A, B, C, and D. And so we can see that, for instance, the first person belongs to categories B, C, D, second one to B, D, third one to A, C. So what we're doing here, if you want to convert the info variable to a bunch of dummy variables, we can use the function getDummies and provide the delimiter that we want to use to split the categories. And what we get as a result, we get another data frame that instead of having one variable info has multiple variables A, B, C, and D. So we can know that the first person, Graham Chapman, is 0 on A and 1 on A, B, C, D. Of course, what you probably want to do, you want to concatenate. So, I mean, many often you probably want to do something like this. You probably want to concatenate this thing full Monte, for instance, with the previous one, let's say this one, and you want to concatenate over the columns axis. You want to put them side by side. But you can see here that this variable, which has been a categorical variable, has now been converted to a bunch of dummy variables. So Graham is 0 on A, 1 on B, 1 on C, 1 on D. John is 0 on A, 1 on B, 0 on C, and 1 on D. Once again, the key here is that this function getDummies is implemented as a vectorized function, so you can call it on the series itself. So to summarize, these functions are very useful when we have strings and when we have lists in our series and data frame. And in the next exercises, we're going to use these functions to process string data from real data sets.